Okay, we are continuing the HTTP protocol. So we are now going to discuss another important topic, and that is web caches or proxy servers. Okay, so web cache, how it works. Let me explain it through an example. I think then it will be clear. For example, a client, this is a network, ComSets University network. Okay, and when this is the gateway means all the user requests from the ComSets users, it passes through this gateway to reach to internet. This is the internet. Okay, so whenever the clients request to internet, send of traffic to internet, so this is passed through the gateway, and this gateway we have a proxy or web caches. Okay, what does it mean? It means that suppose a user wants to send an HTTP request. Okay, that request will pass through proxy server, gateway, cache server, web cache. The web cache, when it receives the HTTP request, it will first process HTTP request that whether the object that is requested by HTTP client in this HTTP request message, it is already stored with the proxy server or not. If it is not stored, then this cache, this proxy server, it forwards the HTTP request to the origin servers, where the server where this HTTP request message is permanently present, and this origin server, it is on the internet. For example, it is the Facebook, and it is present in the America. So when the origin server, when the Facebook receives the HTTP request message, so the server respond with the objects, HTTP response. When the web proxy server, it, for example, this user has requested for Tare Zameen Pe movie. This is a movie, Indian movie, Tare Zameen Pe. This is an Indian movie. Suppose this user has requested for that object, and that object is not present with the proxy server, so it forwarded that to the server, and from this server the Tare Zameen Pe movie, this is stored, this Indian movie is stored here. So this origin server respond, transmit this Tare Zameen Pe movie to the proxy server. So the proxy server keeps one copy of the object, the movie, in its cache, and the response is forwarded to the one copy of the object is forwarded to the client. So the client receives the object. Okay, suppose in this ComSets University, another user, the client, suppose it wants to access the same object, Tare Zameen Pe movie, the same movie. So when this client sends the HTTP request, so it will pass through this proxy server, through this web cache, okay, through this gateway. So when it receives the HTTP request, so it will first check that whether this object, requested object, is present in its cache or not. Since it is present, because this is again requesting the same object, Tare Zameen Pe movie, the Indian movie, and it is already present with the proxy server, so the proxy server will respond from here. This proxy server will not send the traffic to the origin server, but it will respond from here. Okay, so this is the working of web cache. So it means the web cache satisfy client request without involving origin server. So if it is present, the second, for example, when this client receives the request, so it is present already, so it will respond from here, so it will not go to origin server. So what is its benefit? The user, it will reduce the traffic on access link. because when you use this access link, so you are charged, the ComStat University is charged. And here for ComStat, this network is free. This is its own network, local area network, and normally its bandwidth is also high. This is one advantage. And the second advantage is that it will reduce the delay for the subsequent object request. For this client, it will reduce the delay. So user sets browser web access via cache. So normally the user access the web server through web cache, and the web cache is normally installed on the gateway on the proxy server. So the browser sends all HTTP requests to web cache, to cache. So when the cache receives the request, so it's search in its cache that whether the request object is present with it or not. If it is present, then it responds. If it is not present, then it is forwarded to the origin server. If the object is in the cache, then the cache returns the object, for example in this case. And if it is not present, for example in this case it was not present from here, so it was sent to the origin server. But when the object response is received from the origin server, so one copy is maintained in the cache and one copy is sent to the client. Okay, so you can see that the cache, it acts both as a client and server. Why? You can see that, for example, when the cache is forward this request to the origin server, so it is acting as a client. But when this client sends the HTTP request to the cache, so the cache returns the object, it sends the objects. So here it is working as a server. Okay. Typically cache is installed by ISP, by university, by the company, by residential ISP. And why web cache? It reduces the response time. Second, it reduces the traffic on institution access link. Okay, so I have already explained it through example in this example. Okay, so internet is dense with the caches. There are many caches available. So it is also done by the P2P file sharing. So we will discuss it. P2P. I think we will not discuss P2P file sharing in this course, but I will assign you this in an assignment for you to read this topic, and it is also present in this chapter. Okay, let me explain the benefits, the advantage of the web cache use quantitatively. We are going to explain the advantage of web cache through an example, through quantitative results. For example, this is the ComStat University. The ComStat University is attached, this is the router, and this is attached to the internet first router. So this is the access link. For example, this is the PTCL network ISP internet. This is the internet, and this is PTCL ISP. It is connected with the overall internet. And the ComStat University router, it is connected with the internet router. This is the internet first router, and this is the ComStat gateway. Okay. Suppose that the user is accessing objects, and each object is 1 megabits. Suppose from this university, the user, there are 15 objects request per second. That there are 15 requests per second for objects. So 15 objects are requested, 15 requests from the server, from this university for the objects. Okay, 15 requests in 1 second. And the average data rate to browser, that is, you can see that when you send a request for an object, so the object will be returned by the server. So since there are 15 requests per second, and each request is for an object, and each object is 1 MB, so there are 15 MB objects coming from the server. Okay, so the data rate to the browser, from the server to the browser, so there is 15 MB. Why? Because there are 15 requests per second, so the 15 responses from the per second from the server, and each response has an object, and each object is 1 MB. Suppose the RTT is the time, round trip time from this internet router to the origin server, because the client will send the request from here to this gateway. This gateway will send the request from this router to this router. This is the access link delay. First delay is involved from here to here, the time taken from here to here. This is called institution network access time, and then from this router to this router, this is called the access link delay, and from this router to the origin server, this is called internet delay. And suppose this internet delay, it is 2 seconds. It is 2 seconds. And the access link, this access link, its bandwidth is 15 MB. Okay, so let's discuss what is the lane utilization. So you can see that from this lane there are 15 requests per second. How much? 15 requests per second. Okay, so it means that there are 15 requests. In each request, it is suppose the HTTP request message, it is a small size, 1 bit or 1 byte, suppose. So 15 into 1. So this internet, this lane local area network, ComSat network, its bandwidth is 100 Mbps. So 15 into 1, so for example 15 bits, and it is divided by 100, so it is 0.15 lane utilization. And you can see that the link utilization, when the link utilization is less than 1, when it is less than 1, then the delay is very, very small. If the link utilization is equal to 1, then the delay is large. But it is greater than 1, then it is more delay, infinite delay. We have already discussed it in the chapter number 1. So in this case, you can see that the lane utilization is 0.15, so it is very, very less than 1. So it means that the delay is small. Suppose it is microsecond. It is microsecond. The lane delay is microsecond. Okay, for example 1 microsecond, suppose. Now what is the access link utilization? So the request from here, it is 15. It is how much? It is 15. Okay, so and suppose for the lane utilization, the 15 is the request from the client. So 15 will be the response from the server. So here when the object comes in, each object is 1 MB, so 15 into 1, 15 MB, and this lane bandwidth, it is 100 Mbps, so the utilization is 0.15. Now, and these objects also have to pass on this link as well. So on this link, access link, what will be the utilization? So the load on this link, it will be 15 objects in 1 second, and each object is 1 MB, so 15 into 1, this is the total load, and its bandwidth is 15. So in this case, you can see that it is equal to 1. When the lane utilization is equal to 1, so it means that the average delay will be large. Suppose this average delay is in minutes. The access delay is in minutes on this link. Similarly, when the objects are retrieved from origin server, so here the delay is involved. From the router, the request is sent from router to the origin server, and then the object is sent from origin server to this router, and this router forwards the objects on this link, and it is forwarded on this link. So on this link, when the object is forwarded, so we have computed the delay. The delay will be, the lane utilization will be 0.15%. So its delay will be in some microsecond. And when the object is forwarded on this link, objects, so the delay will be some minutes. The access link utilization is 1, so it will be in minutes. And now when the object is forwarded on this part on this, so what will be its delay? Suppose its delay is 2 seconds, as we have assumed it, RTT is 2 seconds. So here in this case the delay is 2 seconds plus minutes plus some microsecond. So the delay will be in minutes. Now as we say that when the object is retrieved by this client from the origin server, so there is 3 links involved. This link, its delay is 2 seconds. This link, its delay is minutes, and this link, its delays in microsecond. So on which link is bottleneck link? Bottleneck link means a link which has larger delay, less bandwidth. So this link is the bottleneck link, the access link. This is the bottleneck. So in this case you say that when you access these 15 objects per second, so it will requires minutes, the delay or time in minutes. And why? Because this link, access link, is the bottleneck link. Now how to solve this problem, how to reduce this delay? So there are two solutions. There are two solutions to reduce the delay from minutes to second. How it is done? Let's see through an example. Suppose that the first solution is that we increase this bandwidth from 15 to 100. When this bandwidth is increased, so its utilization will become 15 into 1. This is the load on this link because 15 objects are requested and each object is 1 MB. So 15 into 1, this object will pass in 1 second, and its bandwidth is 100, so it will be 0.5. So when the link utilization is 0.15, so the delay will be small, as we have explained it in the chapter number 1. This was explained in the chapter number 1. I think the Binish in that class in the lecture number 4, she asked about this thing, and I had explained to her, and I also gave her 2 marks for asking this important question. Okay, so in this case you can see that the delay, it is reduced into seconds. Why? Because the delay on this lane part, it is in microsecond already, and the delay on this access link, it is reduced to microsecond because the bandwidth of this link is increased from 15 to 100, and the delay on this part is already 2 seconds. So it means that the delay is 2 seconds reduced. By increasing the access link bandwidth, the delay is reduced. But what are the costs? This is not can be not increased so much, because if you increase your internet bandwidth, so you have to pay more. So it will, this is not cheap. This will increase the cost for this network, for ComStat. Why? Because they are getting more bandwidth internet. So if you are getting more bandwidth internet, you have to pay more. So it is not cheap, it is costly. This is the first solution. Now let me discuss the second solution. The second solution is that we place a web cache. And the same example, the average object size is 1 MB. There are 15 requests per second for objects. Okay, so the same 15 MB access link and the same RTT from this router to origin server is 2 seconds this time. So the lane utilization will be again 0.15, and it will be, so if the lane utilization is 0.15, okay, there are 15 requests per second and each object is 1 MB, so 15 into 1, and the lane bandwidth is 100, so 15 by 100, it is 0.15. so the lane utilization is 0.15, and if the lane utilization is 0.15, so the delay is small, it is in microsecond. Okay, now if we install the local cache, Local cache means when all the clients, when they want to access objects, so they first have to access the web cache. If the object is present in the web cache, then the web cache will respond from here. So in this case, the access link will not be used. But if the web cache doesn't have the object, then it will forward on this to origin server. So then access link will be used. So if the web cache returns the object, it has the object and it's respond the object, then it will reduce the overhead on this link. So in this case, if we use local web cache, then what will be the overall access link utilization, this link utilization? Because here the load will be reduced, and here also the load will be reduced. So what will be the internet delay? What will be the internet delay? Let's discuss it. And the web cache is cheaper. Why? Just we have to install a server. This is the only cost one time, and already it is used the LAN bandwidth, and it is the LAN bandwidth is 100 MB, so it is very fast as compared to access link MB, and this is your own network, so you don't need to pay. You don't need to pay. Okay. So now we are going to discuss that what will be the access link utilization and what will be the total delay in this case in the local web cache. Suppose usually there is cache hit. What does a cache hit means? First let me explain. Cache hit means that when the client requests for an object, so the client first goes to web cache, and if that object is present in the web cache, so the cache will respond. This is called cache hit. So cache hit means when the client requests an object and the object is present in the cache, so the cache respond. And one is called cache miss. Cache miss means when the object requests for an object and the object is not present in the cache, and then the cache server forward request to origin server. Suppose that the cache hit is 0.4. What does it mean? That the 0.4 request, they can be satisfied from the cache, and the remaining, that is 40% request can be satisfied at the cache, and the remaining 60% they have to access origin server through access link and through internet. So let's do some calculation. So for the 60% object, there will be access link utilization. There will be access link utilization. So it means that 0.6% request, they will be using the internet instead of all. So instead of 1, so 0.6 into 15. Why 15? Because this 15 is the Mbps. So in this case 9 MB is used. 9 MB is used. You know that there are 15 requests per second. You know that there are 15 requests per second, and in these 15, 60% they have to access the access link, not all. Okay, so the object will be 15 into 1 MB, 15 MB. So 15 out of 15 MB, 60% has to pass through this. So 50. So what is the 60% of 15 MB? So it is 9 MB. It is the 9 MB. Okay. So you can see that for the 60% objects, the delay is from the origin server. That is, the delay is from here to here. It is some microsecond. From here to here, it is some minutes, some second. Okay, and from here to here, it is 2 seconds. So you can see that 0.6 into 2.01. Okay, and for this when for 40% it will be satisfied from the web cache. So in this case the time is point some microsecond, zero point 0.4. So if you do add them, so you will get 1.2 second. So this delay, it is very less. It is very less as compared to this 2-second delay in by increasing the cache. You can see that here in this case the delay was how much? The delay was 2 seconds something, and here when we use web cache the delay is reduced to how much? The delay is reduced to 1.2 seconds. So the web cache, and it is cheaper. Okay, so it is less than 100 Mbps link. This delay is less when the access link was 100 Mbps. Okay, so this is cheaper solution. So this is the example, web cache. Okay, now what is the disadvantage of web cache? For example, if the client is accessing an object from origin server and one copy is stored here in the cache, so every time another subsequent client they access the same object, so it will be present in the web cache, so the web cache will respond. And if the object is modified here in the origin server, so here the client will get the older version, not the new version, not the fresh version. This is the disadvantage. So in order to avoid these things, so there are two ways. One is that the web cache, the object should be stored in a web cache for some time, and after this the object should be deleted from the web cache. When the object is deleted from the web cache and the client access, so the object will not be present in the web cache, so the web cache will forward the request to origin server, and the origin server will respond, and fresh copy will be stored in the web cache, and one copy will be returned to the client. If other clients access the same objects, so it will be specified from the web cache, so a fresh copy is present. This is one approach. And the second approach is use conditional GET. What does it mean? Conditional GET means that, for example, Tare Zameen Pe movie, it is stored here in the web cache, and its time is expired. For example, it was stored for 2 hours, and now 2 hours is expired. So the object will not be deleted. When a client requests for the same movie Tare Zameen Pe, it is present in the cache, but its time is expired. 2 hours is expired. So here it will request the origin server that for the Tare Zameen Pe, but this will be conditional. What does conditional means? That if Tare Zameen Pe movie is modified after this date, this time, then please then send me the fresh copy. If it is not modified after this date, then don't send me. This is called conditional GET. And how it gets about the date, so let me explain it to this HTTP response. Okay, sorry. In the HTTP response, when we get the HTTP response, so there is a date which is called last modified. This last modified date is used in the conditional GET. That if the object is not modified after this date, then don't send me the object. If it is modified, then send me. So what is its advantage? Let's discuss it. Let's discuss it. Okay. how it works. Conditional get. In conditional get, don't send object if cache is up to date. For example, if it is in if modified sense. In the if modified sense, what will be the date? The date that was received in the response message last modified. Date last modified date and that was received in the previous response, date will be kept here. And the server will request a message with the if modified sense. So if the object is modified after this date, then the server will send the updated copy. If it is not modified after this date, then the object is not sent. So what is its advantage? The advantage is that what is the advantage? The advantage is that, for example, Tare Zameen Pe movie is 30 GB. So it takes 3 hours. It used 30 GB bandwidth. So if the Tare Zameen Pe movie is not modified, then it will send not modified, only the response, the object is not sent. 30 GB object is not sent. So this is its advantage. If it is modified, then the object is sent, 30 GB is sent. So this is the advantage. If the object is not modified, then it will not be sent. So the bandwidth is saved and the delay will be less, only the response is sent. Because if you retrieve the 30 GB, it will take 3 hours. Okay, suppose. So this is the use of conditional get. Okay, so up to now we have explained HTTP. Okay, so in the next class we are going to start DNS. Okay, so by this the class this class is ends. The class ends. Okay.